Hey folks, okay, from the Frappy today, are the events selecting a female and selecting a student who completed the assignment independent? The question of independence is saying, if you know one event has happened, does it change the probability that the other event has happened? From this problem, we've got female and male students in completed and not completed. Here was the two-way table which summarizes this. At the end of class, there was sort of this hypothesis that all you need to do is look at the two event probabilities by themselves, and if those events are different in terms of their probability, then the events are independent. And that's not quite right. So the probability of having a female was 23 out of 40. The probability of if a student completed the assignment was 30 out of 40. Those two probabilities are not the same. But that doesn't tell us the two events are independent, because it is not bringing into the situation the likelihood that, say, if you choose a woman, given that she's completed the assignment, is that probability different than this probability? So, in order to test for independence, I compare the probability of choosing a woman to the probability of choosing a woman given that the assignment has been completed. Given that the assignment has been completed, there are 30 people, 19 of which are women, for the proportion 0.63. So in this case, these two proportions are different, therefore the events are not independent. Knowing that the assignment was completed has changed the likelihood that I would choose a woman versus just choosing a woman from the population at large. Another example, it's easier to see this when the events actually are independent. Gender and right-handed and left-handedness, 28 students total. Two-way table, 3 female right-handed folks, 1 male right-handed folks, 18 lefty, and 6 male righty. I actually did this backwards because these numbers are stupid, righty and lefty, but it doesn't change anything. Is female independent of being a righty? So again, the hypothesis was we just have to look at the two events' total probabilities. The probability of choosing a female, 21 out of the 28 students is 0.75. The probability of choosing a right-handed person, 4 total out of the 28, 0.14. These two probabilities are different. That is not enough to say the events are independent because we haven't factored in the condition of one happening. So I have to show, in order to prove independence, the probability of choosing a female, 21 out of 28 is 0.75, compared to the probability of choosing a female given that she's right-handed. So, given that they are right-handed, 4 people are right-handed, 3 are female, 3 out of 4, that is also 0.75. This shows me that the likelihood of choosing a female is not changed when I consider the given, yes, she's right-handed. It's the same probability that choosing a female from the population at large. When these two probabilities are the same, then we say the events are independent, because knowing the right-handedness made no difference in determining the likelihood that it was a female. You could also go at it the other way. Both of these are totally fine. You could say the probability of choosing a right-handed person, 4 out of 28, 0.14. What's the probability of choosing a right-handed person given that she's a female? There are 21 females, 3 of whom were right-handed. That is also 0.14. It's not a coincidence. No matter which way you go here, these two probabilities are going to be equal, and that tells me the events are independent. Since the probability doesn't change with the given condition, the events are considered independent. Apologies if that was confusing right in the end of class. Hopefully this clears it up a little bit. Come see me with any questions. Happy to spend a minute or two Wednesday morning talking it over.